later. So the webinar today is about EarthChem and the services for data publication. And so what I'm planning to do is give you a bit of an overview of EarthChem and then show information about the requirements for submitting data to the EarthChem Library and some of our best practices that we try to implement as much as we can. And I really hope to also engage you all in trying to maybe optimize what we have in procedures, in data templates, metadata, and so on to really serve the needs of the CZNet projects and data managers and PIs in the best way possible. So let me just start with explaining EarthChem. EarthChem is a data facility that has been funded by NSF since 2006, so it's over 15 years, and is basically operated in parallel to a couple of other systems that leverage its capabilities and its infrastructure. One is CISA, the System for Earth Sample Registration that we have already touched on in previous meetings of the critical zone. But that we will also, explain in more detail in 2 weeks from today, I think. The other system that is much younger is the Astromaterials data system that is funded by NASA, and it is basically a clone of EarthChem, but deals with geochemical data for astromaterial samples, such as all the samples returned by Apollo missions from the moon, with meteorites and cosmic dust, all kinds of stuff that is curated at the Johnson Space Center. Oops, why do I not move forward? Okay, so the data services that directly pertain to EarthChem are the services for data publication and preservation, so repository, that is the EarthChem Library. In conjunction with that, we have the community collections that is sort of a component that was put in place fairly recently, like a year ago, based on community demands and continues to grow. These are, somewhere comparable to communities in HydroShare, but not quite. And then the third component of EarthChem are the syntheses. These are data compilations that I will briefly explain later, also with the purpose to find out from all of you if, the synthesis of CZNet geochemical data is something that would help the science of all these projects move forward. Just to show very briefly how these systems relate. So the EarthChem Library is the repository that lives entirely on user submissions. We will go into that. And the data that is submitted to the EarthChem Library that lies within the scope of these synthesis collections will actually be taken from the EarthChem Library by our curators and ingested into these synthesis databases. We also run the EarthChem portal, which in addition to the data from the EarthChem synthesis, integrates with external geochemical databases and makes all of the content of these different databases accessible through a single search and data exploration website. EarthChem has a very broad community that uses it because it basically pertains to all communities that generate geochemical data. And, you know, as you well know, geochemical data can be generated on many different materials, from rocks and sediments to soils and water. And basically all of these communities contribute data to EarthChem. And so it serves very different communities such as high temperature geochemistry, low temperature geochemistry, geochronology, marine geology, and so on. You see even, I mean, geohealth is one of the newer domains that has started to use the EarthChem library. All right, it's compared to other systems, it's not a huge repository yet. We have right now over 1,000 data sets, and it keeps growing faster, as you can see in the lower left corner. With the implementation of FAIR principles by publishers, the submission rate to the EarthChem library has grown a lot in 2020, 21. So that is a fantastic sort of development for us. The big collections are really these syntheses that are put together from published articles in the scientific literature, and you know, in the PetDB synthesis, we now approaching 7 million individual analytical measurements and over 30 million at the portal. An important aspect is that EarthChem tries to operate following accepted international best practices and principles. And everybody has been talking about FAIR as principles for findable, accessible, interoperable, and reusable data. But we also ensure that we follow the trust principles for transparency, responsibility, user focus, sustainability, and technology that really apply to the repository itself and are implemented through the Core Trust Seal certification. In addition, we're starting to carefully look at the CARE principles for indigenous data governance, because we do have both in EarthChem and in CSAR data and samples that are collected on properties of indigenous peoples in conjunction with all kinds of projects that are, for example, executed in the Arctic and so on. So we really want to be ethical in the management of our data. So EarthChem Library, that's the data repository that you really care about, and that is in the process of being linked up with the CZ, our critical zone data submission portal that we demoed just recently to all of the CZNet community. The EarthChem library focuses on publishing, disseminating, and archiving content that is contributed by users. What's the content? Again, I've showed earlier these two boxes already. The library focuses on sample-based data primarily, but not everything are sample-based data. But it's data from different sample types, data that pertains to different properties of samples, be they compositional, chemical, physical, and it's different types of observations, such as lab analytical data or field observations. We have primarily new analytical data that often is published in conjunction with scientific articles, but there are also compilations of data that people have made from the published literature or the published literature and our synthesis databases. And these are submitted for preservation and specifically for reproducibility of any results presented in papers. We also do accept reports and documents such as method descriptions. And that seems will be evolving into a method directory that we hope to start developing in a year from now. We do accept images at the moment, but I have to say that we do have size limitations because our infrastructure is currently not set up to take large volumes of data. You see there our current size limitations are 50 megabytes for individual files and 400 megabytes per submission, which can be up to 20 files large. But we have an increasing number of requests to store images, primarily thin section photos and backscatter electron images, and so on. And we are in communication with NSF to figure out how to accommodate these. As I said, we follow the FAIR principles with all the, the different components, requirements that are needed. So we do assign DOIs, we register data sets with DataCite as a catalog. We do long-term archiving in Amazon. We make our data available both in human readable and machine readable format. We use even other persistent identifiers and we link them as much as possible. You'll see that in a moment. We offer licenses for the submitted data and so on. So I think that's, you know, the features that every FAIR or every repository that claims to take care of FAIR data needs to follow. But as I mentioned earlier, we also follow these trust principles. We have our application for COTRUST seal certification ready, which will likely take another year. But we have already gone through some review processes with publishers who now recommend EarthChem as a trusted repository for their journals. AGU and Nature are two of the examples. What are our services? So first of all, we allow online submission of the description metadata of any data sets and the files. You need to have a user account in order to do that. Once you have a user account, you also have a user dashboard that shows you previous submissions, but it also shows you any incomplete submissions that are saved and can be completed at a later time. Very important for us is that we execute a review. Our curators follow an editorial process with a review of metadata completeness and correctness. They often get back to users to enhance the data sets, and that's likely going to happen when you start submitting things until you've got the routine in. So as I just said, there's user support, but we also have guidelines, tutorials, videos available to support the data submission. Very important is that we offer templates for organizing data and metadata, and we allow communities to suggest best practices and develop their templates that we review and make sure that they align with overarching best practices. So this is something that I think the critical zone network should consider if there are specific sample types or data types that need to be accommodated. The EarthChem library also sets or allows users actually to set embargo periods after submission. and those can be up to 2 years long. They mainly used right now by users who submit their data set while the manuscript while their publication is still under review, and then the data sets get released the moment the manuscript is published. We have policies for versioning, which we can dive into deeper. But if you have new versions of a data set, then it will be linked through metadata with the older data set, and the landing pages show the older data, the older versions or newer versions on the landing pages. We try to make sure that we link the data sets as much as possible with other resources, such as publications. We link with samples, funding awards, field programs or cruises. We have also established links with, for example, volcanoes, if there are directories and unique identifiers of entities available. So for volcanoes, for example, there is a globally governed set of volcano numbers with landing pages at the Global Volcanism Program. So you can actually go from data sets to these landing pages, and hopefully in the future the other way around as well. And as I said, we allow users to select licenses to ensure there is appropriate credit and clarity for reuse. Here is an overview of the workflow in publishing data and depositing data. So as a research data depositor, you come to the website in the future, obviously the data submission hub. But your responsibility is to prepare the data using our data submission guidelines and templates, and specifically also to have your samples already registered with globally unique and persistent identifiers, preferably in our case with IGSN, so that you can fill out the templates, the metadata, and the metadata forms in the online submission tool, and then submit your data file. And then it goes into the hands of the EarthChem data curator, who gets alerted when a new submission comes in. The curator will review the files, the documentation and metadata, and check if they are compliant with our expectations and policies, and if they are as complete as possible. If everything is okay, they push a button and ingest the file into the repository, assign the DOI, and submit the data set to the long-term archive. And that also triggers a notification to you as depositor. If there are issues with the file, the curator will get back to you with an email and basically give specific instructions how to fix the data set, and also suggestions for enriching the metadata and so on, to make the data set even fairer than it initially was. Oops, why does it not go forward? Okay, just a quick look at the metadata that we have in the EarthChem library. So for the catalog that basically contains metadata for the identifier for data site, we follow the data set metadata kernel as much as possible. There is bibliographical information such as title, authors, and keywords. And then we hold the related identifiers, which are DOIs for publications, IGSNs for samples, ORCIDs for the authors, if we can get them, and so on. And in the catalog metadata, we also have the version linking implemented, and the licenses are part of those catalog metadata. But then there is a much richer set of provenance metadata that reside in these data templates within the data files. Those pertain to the analytical methods or observation methods applied, and include something like the technique. Is it X-ray diffraction or X-ray fluorescence? Is it mass spectrometry? What's the instrument, in which lab were the analyses done, who was the analyst, and so on. Then a lot of information, or as much as possible at least, about the data quality, precision, what was the calibration, specifically also measurements of reference materials, which give the community indication of the data quality any reuser needs to know. It's really important, if data were normalized to standards, to know that, so they are actually comparable to other measurements. And then last but not least, there are the metadata about samples, from the geospatial location to collection method, collection time, unique identifier, and so on. As I said, we make these templates available, and there are different templates for different types of analyses, because we try to help the people who submit their data to us as much as possible to have the appropriate metadata as complete as possible. So here, for example, is shown the bulk analysis template, and then you can always get a template where we provide example data and metadata in it, just to help understand how the template should be used. There are in situ analysis and core data from core samples, which have different metadata fields that describe the cores actually, and the samples, where in the core the samples were from, and so on. And increasingly, we are getting templates that are contributed by the community, and we have specific templates with a lot of effort done by an initiative in the TEFRA community that includes time series analyses and TEFRA analyses templates. We have received templates for volcanic groundwater. We have templates for volcanic gases, and so on. And then I've also listed here the clumped isotope community and the experimental petrology community. These are obviously, experiments need different metadata and data quality information than time series data. So that, again, I put down here the critical zone network. It would be really great if there is a need to make data produced within the CZNet more consistent, that we develop together with you templates that pertain to data generated in the CZNet community. Quick look at the data submission tool authentication and the form. This would only be for you to use in the near future, as long as EarthChem is not yet linked to the data submission hub. But hopefully that will happen soon, and we will start testing the submission. These are just web forms, basically, that capture all the catalog metadata. So I just wanted to point out a few important best practices that we also try to endorse as much as we can. Data has to be absolutely in a usable form. It's in old days, it's to some degree, it's hardly understandable anymore, but many data tables and papers were actually in PDF or JPEG format and so on. And we still get submissions once in a while where people send us just an image of a data table. That is absolutely not acceptable. As I said, we encourage metadata to be as rich as possible. And for compilation specifically, we enforce the rule that all data sources from which data had been compiled are listed to give credit to these original data producers. What we have to remind people of over and over again is to avoid abbreviations. If you need to use them, they need to be defined inside your data set in the data template. Again, lots of guidance is provided. We have tutorials and submission guidelines. But if those are not enough, there is also a form that you can fill out and submit any questions to us or send us an email directly to info@earthchem.org. We have a very basic search. It's on our high priority to-do list to improve that search. So right now, I have just given an example here. If you put in keyword critical zone or soil or whatever you might want to do, you will get a list of data sites back. And you can see here that from the critical zone, we have some researchers who are very active in submitting their data sets to us, but you know, it's a total now of nearly 70 records that are tagged as belonging to critical zone research. When you click on it, you get to the click on the DOI or on the title, you get to the landing page here with the abstract and instructions how to cite the data set. You will also see related publications if they were provided by the data submitter, the license and links to funding awards. And then there is the download button for the data set, but you will also, under related information, for example, see a list of all the samples for which data are included in this data set with the IGSN that then links out to the landing page in the system for a sample registration with all the detailed information about the sample. What you can also see here under related information is the link to the older version of this data set, where it says is new version of this given data set. Discovery and access is also provided because we have worked with EarthCube on the geocodes effort and with Data One as well to expose metadata through schema.org. So all of the data sets in the EarthChem library can be discovered via Data One as well as through Google Data Search. So quickly, I wanted to bring up these EarthChem communities. This was implemented based on fairly frequent user requests who wanted to have a place where they could share and promote best practices that they had developed through community efforts. What we asked for is really a demonstration of a community effort that has endorsed these best practices, templates, standards. For example, the TEFRA community had a grant from NSF to run workshops and develop these best practices. And they published these. They have guidance in the Zenodo repository and their templates there. And they are about to, I think the publication has been submitted for a while and should be coming out pretty soon, that explains all these TEFRA best practices. Similar efforts have happened for the clumped isotopes and experimental petrology. So again, that's a possibility for the critical zone community to also make sure their data are more consistently documented, use common vocabularies, and so on. So we have recently established a CZNet community, particularly driven by the fact that we want to make sure data submissions that are coming at the moment directly to the EarthChem library are properly tagged as belonging to the CZNet community. So if you have data that you want to submit before the data submission hub is active and in production, you should go to the CZNet community and start submission there. Here, as I point out, there's submit CZ data to the EarthChem library. That will automatically tag your data set as belonging to the critical zone network. We have a pending proposal for our next phase of operations. It's pending at NSF, and we should hear actually any day. So I just wanted to give you an outlook of what's to come. Hopefully in the next 2 to 3 years, we will enhance the implementation of fair, care, and trust principles by making sure that there is a richer set of metadata available in the catalog for human and machine actionable search and access. We had already started to evaluate and hope to implement fairness indicators to show how compliant a data set is with respect to interoperability, reusability specifically. And as I mentioned earlier, we want to build a specific repository for methods so that methods can be described in more detail with very method-specific metadata. And these methods would then get a unique identifier, get a DOI that would be linked to the data sets that were generated by that specific method. The big advantage is that this method directory should then allow investigators to store methods so they don't have to fill out the templates over and over again, but simply if a new data set is generated in a lab, it can be linked up with that method, which on the other hand, can be updated with new reference material measurements or different instrument settings, but a core set of metadata would always be available in that method directory. The other thing that we plan to do is to make sure that the data submitted to the EarthChem library are more automatically ingested into the EarthChem syntheses. And that's a pretty big effort that we have been pursuing for quite a while. It is complicated because there is quite a bit of data validation, quality control, harmonization of vocabularies, and so on involved in doing that. That is currently done manually by data curators, but is an interesting data science project. And we're working with other efforts, specifically with the GeoRock database, but other geochemical databases that are currently emerging globally on creating ways, specifically JSON schemas and vocabularies that align, that create these sort of consistent structures for geochemical data to flow into synthesis databases in a consistent manner, not just at EarthChem. Another very important improvement that we want to make is the addition of spatial context for in situ analysis, which is becoming increasingly important as more and more geochemical analyses are actually done with laser ablation on very high resolution approaches that require knowledge of where on a given sample an analytical spot was located. So we need to make an upgrade of the systems to keep that information. And again, that leads back to the need for having an image repository. So I think at this point, I'm going to stop here and actually stop sharing so I can see you all better and get questions from you. And if there's time at the end of the meeting, then I can say a few words about the synthesis, because I think there may be potentially interest within the ZZNet community to also build a synthesis of soil or other, related geochemistry that makes the data more analysis ready. So, okay, I stopped talking and wonder if anybody has a question, if you want to raise your hand or put it in the chat. Was that too overwhelming? Has any one of you already used EarthChem before? Nobody? Oh, Kevin has a question.
Yep, I have a question. I'm brand new to this sort of thing, and I'm still working through the CSAR process. And CSAR process, is that going to generate an IGSN? IGSN, oh, excited. What that
global
is actually
sample number, global sample number.
Global sample number. Mm-hmm. So is that kind of the purpose of the CSAR sort of thing? So
yes, CSAR is basically the agent who registers your sample with the central registry. Now the IGSN, it's an interest, and we're going to talk about that in 2 weeks when we have CSAR as the topic of the webinar. Is it in 2 weeks or in 4 weeks, Jeff?
2 weeks, I believe.
In 2 weeks. Anyway, so the IGSN was developed by CSAR. Actually, it was a centralized system that provided the unique identifiers. But then the IGSN basically needed to split up because there was a globally interest in using it, and not everybody could use CSAR. And other organizations, be it geological surveys in the UK and Australia and so on, they set up their own system that is basically parallel to CSAR, and they all talk to a central registry, which currently is still at the Geoscience Research Center GFZ in Potsdam in Germany, if you're familiar with that. But we have just in the past October entered a partnership with DataCite, and the IGSN registration service is moving to DataCite and will be operated by DataCite in the future.
And then a follow-up on that. So I'm working with CSAR right now to try and get some different data, metadata definitions that are more appropriate for some of the CZ work that I'm doing. But one of the questions that a lot of the people in my group have, and that has to do with trying to understand versioning. And so, we're generating data sets. We have a lot of data, but we're generating more in the future. And so I'm trying to understand if that is the appropriate terminology for, adding additional data to that data set. Is that versioning, or is that something different?
I would say that's something different. We should try to figure out how to best link that. I mean, I'm engaging Lucy here as well. You might have thoughts, but currently the way we've used versioning is really if somebody has submitted a data set and kept it private while review of their paper was going on, and then the reviewer said, well, you should add, this data, or these data are wrong, or whatever. So the actual data set itself changed. And so we said, okay, we register a new version. How are we going to deal with linking data sets that pertain to a broader project. I mean, the project would link via and the funding award, but I don't think that's what you're really looking for, right?
Right.
So I think,
Kevin, is this a chunking issue? Are you wondering
Yes.
about how to chunk your data over time?
Yes, that is. So that's my question, because we're taking the same types of measurements, in different reasons, sort of thing, but it's all using the same methodology, and so it repeats. And in my mind, it still is one data set, but maybe that's not appropriate for.
Yeah, I can see. I mean, it could well be an implementation that's very similar to the version, but is pertains to a data group or a data series or something, where basically we would enter the DOI of the next data set into the metadata of the previous published data sets. And that way you can see on the landing page that there are different data sets that pertain to a common theme. But I think this is a really interesting use case where we should think about, how do you link data sets that are thematically or project-wise related, but are not different versions of the same data set, right? I think that's a great thing to discuss and implement.
Kevin, do you imagine that those data sets will eventually be finalized? So you're collecting more data over time. Maybe you're chunking it at various points, like you're sending batches to a lab and you get a set of results back, and then you send another batch to the lab and you get another set. Like, will you eventually finish that data set?
Yes, those data sets will be finished, but it will take, on the order of several years, probably, for some of these. But then again, I want to be able to publish on data, in the interim sort of thing as well, before the entire data set is completed.
And that's why, we're really trying to, for, data sets that are part of publications, they can change, right? So you submit something and, the moment it's out for use, it can change. So that's why the concept that we currently have that defines a data set wouldn't work for these adding on data sets. But maybe there is a way to actually generate, an umbrella entity that doesn't sit in the repository, but rather, well, it could well be. But that's an exercise to go through. But I'm glad you mentioned that, because it's important.
And this doesn't necessarily have to do with EarthChem, but it also goes along lines with I'm creating a national wind erosion network site that's going to have a lot of meteorological data associated with it. And I've been hearing that Zenodo is a potential place for that, because they're able to continually upload new bits of data to go along with it, sort of thing. So especially for meteorological data.
Interesting. Yeah.
So it wasn't thinking anything like that in EarthChem, obviously, but
no. I think the way Zenodo is handling their DOIs is they do versioning, and when they issue a DOI for a data set, it always points at the newest version of the data set, which is a little bit tricky, because if you've cited a data set using a DOI and it was a snapshot in time that was something at one point, and that same DOI is pointing at something different in the future, you sort of have to know that and march back through time. So there's various approaches to this that different repositories are taking, and Zenodo has a little different policy there.
Cool. And I'm glad that you're registering with IGSN. It's actually really important to note that the registration of samples should happen very early in the field, so that while you're actually describing things in the samples in the field. When you're taking them into the lab, the IGSN is already associated with it. That it's not the afterthought at the end when you submit to EarthChem, oh my God, I need to register my sample, right? It really, best practice is to do it as early as possible in the process. So Derek, you said you have questions about the synthesis. Is there anybody else who had a question about the EarthChem library? Because otherwise I actually listen to your question first, and then I see if it's worth showing any further information about the synthesis, or actually showing you a quick demo of, you know, the way it works.
Yeah, I think that's actually pretty much what I'm after. I was after a few more details and kind of the timeline and things like that. So if you have something prepared, that'd be great.
Well, I have, yeah, let me just get back to the sharing. Whoops. There is grandchild, sorry. Okay, so I mean, the insight has always been that, you know, when you have 500 data sets that you want to work with, you know, it's a pain, and you're spending endless time in compiling data from different data sets unless they really are in a consistent format, which geochemistry usually isn't. So these syntheses were actually the beginning of EarthChem, which is kind of funny. The repository came later. So the synthesis databases, the oldest one is PetDB, that actually started in 1996, are compilations of published data that our curators take from the literature and ingest into relational databases. And currently, I mean, PetDB, for example, has anything from major elements, trace elements, isotope ratios, and so on. And we have always focused these syntheses on certain scientific themes, as we call them. So there was a big program at NSF called RIDGE that studied mid-ocean ridges. That was the first compilation we did. Mantle xenoliths, diamonds. We've done, you know, all kinds of different focus, but we tried to work during the critical zone observatories funding with investigators, specifically Sue Brantley and her team at Penn State, to build a critical zone synthesis. And for a lot of reasons, long stories, it was never really completed. And so this, I think the ZZNet is now an opportunity to think about it again. What these syntheses do, they basically allow you to search across data sets at the level of, you know, to find and retrieve individual measurements and data for individual samples. So we have over the time built different versions of interactive search interfaces to select data and basically create customized data sets from what is in the database. We have recently changed the architecture of these synthesis databases to be entirely API driven, and we are in the process of building the APIs that will in the future allow machine access to these databases. So the foundation is actually the observation data model, ODM2, where we take data sets apart into these different components of sampling feature, methodology, feature of interest, and results that are linked through the concept of an action. So this is, you know, how you can search PetDB at the moment. And I've given you a few examples here of questions you can ask, and we could translate them somehow into questions that pertain to soil geochemistry and so on. But, you know, you can ask, give me all rare earth elements for basaltic samples that have a niobium content less than 2 ppm. That would be a search by sample type, where you can select basaltic samples. You select by chemistry, saying I want niobium to be less than 2 ppm. And then for the output, you select all of the rare earth element data, and you would get a data set that's basically compiled from potentially hundreds of publications into something that you can immediately use. If you are interested, I think this is my last slide, because I thought maybe I can just go online. Do you want to see a small demo?
Sure, I'm interested.
Demos usually don't work very well, so there's always something wrong, but let's see. So let's go to EarthChem and to PetDB. So we can go to location. We can.
Can you share your screen again?
Oh, I'm not sharing anymore. Oh, stupid me. Yes, I am so sorry. So now I'm obviously already in PetDB. What is this block here? Do you see this white block at the top as well? That's weird.
I think it looks normal on our end.
Yeah, it looks normal on our end.
Oh, sorry. So something just happened because I connected my computer to the power, which, can you still see it?
Yeah.
Okay, great.
So we're only seeing part of your browser. It looks like we're not seeing your whole screen.
Okay, let me see what I can do. That's weird though. Let me stop sharing and I start it again. And I actually hoping it's going to be better.
Yep, that's better.
That's better. Okay, so I actually came here from when you are at EarthChem, you can go to access data, to syntheses, and then straight to PetDB. So these are all the different options you have to select your data. And I went here to set location data, where you can basically get a nice map with the global multi-resolution topography on it. That will allow you to now set the right polygon. I'm just doing really something random here, right? So now you can see the samples that it has retrieved. You can view the samples on a map here that exist. You can click on the dots, and in some cases, these are obviously locations where multiple samples are available. And just what you usually want to do really is download data. So in this case, you have the choice to get data for bulk analysis, which means rock samples. You have the choice to just get analytical data for the minerals in these samples, or melt inclusion data. This, as I said, this system is very much oriented to igneous petrology. So let's just go to rock samples. And so you can see here a list of all the different chemical variables that exist in the database. Those is everything that's listed here. And the ones that have this blue check mark next to it are available for the samples that are in your selection right now. So as I mentioned earlier, was, for example, we want rare earth elements and trace elements, you can clear all of these and say, okay, now I want to view and download the results. And here come the results that are available. These are all from, it's 3 different papers in this case. You can see here all the different chemical variables, or the trace elements and rare earth elements. Oops, that was not what I wanted. Now I need to do it again. You can actually link to the sample landing page in PetDB that gives you a summary of everything that's available about this sample, information about its lithology, descriptions, if they are available, like textual descriptions. Very often they're not available, location, the feature of interest here, and then all the different analyses that have been provided. You can go and see information about the publication, and then it does give you more information about the publication and so on, about expeditions, in this case, obviously unknown. And here is all the information about the analytical method that pertains to these data, you know, where it was done, which laboratory, with which method was used, and so on. So that's the very rapid overview. Was that sufficient? Did it give an impression of?
Yeah, that's great. Very, I mean, super impressive kind of feat to pull off, as somebody who spent some time synthesizing data. I actually have to run and teach a class in 1 minute, but my other question is, so that was, you know, for a lot of the rock samples, is something like that in the works for, say, you know, other data types, like, you know, soil carbon? That would be my emphasis, you know, things like that. Is that an expanding system right now? Or?
It's not. I mean, the focus right now for the curators are igneous rocks primarily, and melt inclusions, volcanic gases, and so on. But this is something I wanted to bring up in one of the future PI meetings, maybe, if this could be a project proposed to the synthesis. Mm-hmm. Right? If we could get a group of project PIs together, or people who are interested in this, and participate in some sort of crowdsourcing effort to compile the data, we would be happy to support that. We do that currently with other science projects like Converse, which is a volcanism project. There are students in different places who basically compile the data, and we ingest them then. So that's definitely possible. The TEFRA group is doing it now. You know, there are opportunities there. So I brought this really up in order to trigger, you know, that thought process. Is there a need for it? And if yes, what can we do?
Awesome. Thank you. I have to run, but I'm sure we'll iterate and be in touch.
Yeah, and
thank
you know,
you so much.
If you have more questions, just send me an email.
All right. Thank you.
All right, we're actually at the hour. I hope it was useful.
Thanks, Kerstin.
Thank you. Bye.